This is the video for accelerated geometry for section 4.1 on solving quadratic equations by graphing and factoring. Key vocabulary in this lesson is quadratic equation, zero of a function, root of an equation, binomial, and trinomial. By the end of this lesson, you should be able to answer the question of how do you solve quadratic equations by factoring and graphing. A zero of a function is the value of the input x, which makes the output f of x equal to 0. The zero of a function are the x-intercepts. Unlike linear functions, which have no more than one zero, quadratic functions can have two, as shown on the right. So it crosses the x-axis here, and it crosses the x-axis here. These two would be what we call the zeros. And it's also important to note that the zeros are always symmetric about the axis of symmetry, which we will talk more about the axis of symmetry a little bit later. So in this example, it says, what are the zeros of the graph? So I'm literally going to look at the graph and see where does it cross the x-axis. It crosses the x-axis here, and it crosses the x-axis here. So the zeros of the functions would be at x equals 2 and x equals 4. What other information can we get from the graph? We can see that the vertex, which is where it changes direction, is located right here, which is at the ordered pair of 3, -1. We can see what we call the axis of symmetry, which goes through the vertex. So this imaginary line here. Which is at x equals 3. And we also can see that we have a y-intercept, which is where it crosses the y-axis, which is over here. So it's either at y equals 8, or we could just write it as an ordered pair of 0, 8. Our next question says, if you're looking at the table of values, how would you know where the zeros are? Well, your zeros are when the y values are 0. So for the table above, our table would look something like this. You would have an x and your y, and it would show that at 2 we get out 0, at 3 we get out -1, and at 4 we get out 0. So you can see here that the y values are 0, which tells you that 2 and 4 are your zeros. Our next example says, what are the zeros of the graph? So in this graph, it never crosses the x-axis. So we would say that there are no real zeros since the graph never crosses the x-axis. If you're looking at the table of values, how can you tell this? Well, the y value will never be 0. The solution to a quadratic equation of the form of ax squared plus bx plus c equals 0 are roots. The roots of an equation are the values of the variables that make the equation true. You can find the roots of some quadratic equations by factoring and applying the zero product property. So we have essentially 4 words that kind of mean the same thing, but when we're talking about functions, we're going to refer to them as zeros or x-intercepts. If we're talking about equations, we're going to refer to them as solutions or roots. Our zero product property states that if the product of 2 quantities equal 0, then one of them has to be 0. So in just a second, we're going to factor. And so when we get our two factors here, one of them has to be 0 for the whole thing to be 0. And this will make more sense in just a second when we work some. Just a reminder of some things that we've already talked about before. Our special products. So we have the difference of squares rule and our perfect square trinomial rule. The quadratic expressions with two terms are called binomials. And the quadratic expressions with three terms are what we call trinomials. So let's work some examples here. It says, find the zeros of each function by factoring. So I notice that this has a 1 here, so I know this is going to factor to two things with x and x. And the only numbers that multiply to be negative 12 and add to be negative 4 would be a negative 6 and a positive 2. And since we're finding the zeros, we're going to equal this to 0. So this is where our zero product property comes into play. Since this times this has to equal 0, one of these, if not both of these, have to be 0. So then from this point, we're going to take the first factor of x minus 6, set it equal to 0. Take the second factor and set it equal to 0. So this would give me that x equals 6, and this gives me that x equals negative 2. So those are our two answers. Let's try another one. So we're going to set this equal to 0. When factoring, our first question is greatest common factor. So between 3 and 18, I can pull out a 3. Between x squared and x, I can pull out an x. So that leaves me with x plus 6. So now I can say that 3x has to equal 0, and or x plus 6 has to equal 0. So if I divide both sides by 3, that tells me that x has to be 0 and negative 6. So on C, we have different parts on each side. So your goal is to get it equal to 0 first. So all I'm going to do is subtract the 25 over to the other side. So that's going to give me 4x squared minus 25 equals 0. And then from there I can factor it, so there's not a greatest common factor. However, I do realize that this is the difference of squares. So that's going to factor to 2x plus 5 and 2x minus 5. So 2x plus 5 equals 0, or 2x minus 5 equals 0. Subtract the 5 over here, and that gives me 2x equals negative 5. So x equals negative 5 halves. And this one gives me 2x equals 5. So x equals 5 halves. For D, we're going to get everything on one side, so I'm going to bring the negative 48 over and add 32 to both sides, which is going to give me 18x squared minus 48x plus 32 equals 0. So greatest common factor first, so I'm going to pull out a 2. So now I have, from here, I can say that 2 has to equal 0, or 9x squared minus 24x plus 16 equals 0. Well, this is never going to happen. So you could essentially ignore that now, because 2 is never going to equal 0. So I have to keep factoring this. If you didn't see that this was the perfect square trinomial, then you could factor it as we did before, with multiplying 9 times 16 and finding the two numbers that add to be negative 24. But I recognize this as a perfect square trinomial, so I know that's going to factor to 3x minus 4 squared, which essentially here you have the same thing written out twice. which means you really only need to work it once. So that's going to give me 3x equals 4 and x equals 4/3. One last one. So if I factor this, there's no GCF. It's not the difference of squares. It's not a perfect square trinomial. So 6 times -5 is -30. So two numbers that multiply to -30 and add to be 13 would be 15 and -2. So now that gives me 6x squared plus 15x minus 2x minus 5. Group the first two, group the second two. Yes, there's really addition going on between those. Greatest common factor here would be a 3x. That leaves me with 2x plus 3. I'm sorry, that leaves you with 2x plus 5, because 3 times 5 is 15. Here, I can pull out a -1 so that my signs become the same as the other one. So this factors to 3x minus 1 and 2x plus 5. And we're setting that equal to 0. So that tells me that 3x minus 1 equals 0, or 2x plus 5 equals 0. This tells me that 3x equals 1 and x equals 1/3. This tells me that 2x equals -5 and x equals -5/2. One last example. It says write a quadratic function in standard form with the zeros of -2 and 0. So essentially that tells you that when you solved, you had x equals -2 and x equals 6. So if we work this backwards, the opposite of subtraction would be adding. So really that tells me that x plus 2 had to equal 0 and that x minus 6 had to be 0, which tells me that my function would be the product of x plus 2 times x minus 6. And then we're going to FOIL this out. So x times x is x squared. That's going to give me -6x plus 2x minus 12. So my final answer would be x squared minus 4x minus 12.